Okay. No, let's not do that. So today we're going to introduce vector valued functions, which is essentially what happens when the world of vectors meets the world of parametric equations and they collide.
Is this a crossover?
Yeah. Well, I can scroll down.
This can't be that hard.
No, don't say that. No.
Wait, so it's just it's just where a vector has the same components as the x and y would.
Well, it's essentially we take our set of parametric equations, f of t and g of t, how we expressed, we had x equals and y equals. And what we're going to do is, like you said, we're going to put them in the components of a vector. That was the projection vector.
I forgot what it was called, but I knew it was.
Yeah, where you divide by the magnitudes and stuff.
You know what? I can maybe hire a review and stuff like that. Because I better done.
I watched the projection video too.
Well, how do you feel about the review?
Oh, really good. I think that was one of the easier quizzes. That was the first quiz that everybody finished before the bell rang.
Okay, I'm gonna wait for you to copy everything down before I explain all of these weird vectors that are happening right now.
Is this how we get from like parametric to polar?
No.
Oh no.
No. I mean, it's kind of. Yes and no.
No.
Yes and no.
Oh boy.
Can we have like another Thanksgiving break?
No.
See, all my other classes,
There's
all
now-
my
This
other
happens
classes
in
were like, let's have
exactly a
food day on
month, okay?
Tuesday, and then I had a quiz.
Yep. Sorry, I'm just mean.
Yep.
All right. So what happens is instead of like us plugging in a t value and we get a coordinate, we plug in a t value and we get a vector. But the vector is going to plot the path of our curve. So where the vector ends, when you're in standard form, that's where our path is. Okay. So we're still doing parametric equations. They're just being drawn with vectors.
Why would you do it that way?
Why not?
Art.
Because arts.
My
It's
gosh.
kind of
You
like
know
an
what
integral,
Josh found?
sort of.
Yeah.
This dude worked on that art project all weekend because he was gone for Allstate on Thursday, Friday, and then he left it at home.
Okay. So we have probably graphed the parametric equation set of x equals cosine t, y equals sine of t. If we wanted the vector valued function, okay, we would write it as cosine of ti plus sine of tj. Okay. Advantage, we have only one equation instead of two. Okay.
Sine of t.
I was right.
The sign of titanium.
Oh, that is titanium.
Yep.
But it's not as fun as TJ. That's a name.
Nobody's name in here though.
Oh, it's
Darn
Jefferson.
it. Change your name. Change your name right
What
now.
if everybody called Thomas Jefferson TJ?
Hey,
Signed it so hard.
I think we should do it.
Put your TJ.
Okay. What is
TJ.
p of 0?
what?
Bracket 1.
Gosh, struggled there for a
One
minute.
I, right? So we have this vector, 1i, What's P of pi over 2? Okay,
J.
so here's vector j. Okay, and we could be really obnoxious and say, you know, pi or p of, 13 pi over, or excuse me, like 7 pi over 12 and 3 pi over 4 and all sorts of obnoxious angles, but you know that each of these vectors are going to keep going in this direction. We'll just pick some easy ones, right? What about how about we do 3 pi over 4? What would that vector be? Kind of.
That's why I okay.
Okay. P of pi, like pumpkin pie, that we all.
That's so
You
late.
can
That
say-
some of you may have gotten to eat. Would take us to there. Okay. P of 3 pi over 2 would give us this vector. Okay. So as our vectors, I didn't do a great job with that. Okay, but there would be our circle, right? That we get the same thing from our parametric equations as we do our vector value function, but we have a one function drawn by vectors. Okay. So what are we gonna do?
We're just gonna leave it there and say good for the day.
Nice picture.
Yeah, that was
It's a
pretty.
clock.
Let's not do it again.
Okay. First of all, let's talk about domain. And I'm actually going to change this example to t to the 1 half.
Let's just go with the main question.
Cinti.
You know,
So what famous?
okay, so when we consider the domain of a vector value function, what do we have to think about?
The numbers we can plug in.
Okay.
You can't plug in any negative numbers because
What I would do is I would think about each component separately. So what would be the domain of sine of t?
all real
All real
numbers.
What would be the domain of t to the 1 half?
0 to infinity.
Okay. Where do those overlap?
0 to infinity.
So then the domain of the vector value function is 0 to infinity.
So is that the domain of t?
That's the domain of R,
Okay.
where t is the variable that we consider for our domain.
Boom.
So we're not looking at like the x-axis or the y-axis. It's t. That is the domain.
Yes.
Okay.
Like we're looking at the independent variable t.
Okay.
Yes, and what we can plug into our independent variable t.
So that's not going to look on a graph. You're not going to see like here's a 0 to infinity on the graph
Right.
because it's t and it's going to make all the points.
Right. Yes. Okay. All right. Let's graph this one.
Now I can see why the I and the J.
If we were getting all sure you're happy with the parentheses, then the J would go outside of everything else, right?
Like you got like the sine of
Sine
t. Okay. So when we had our parametric equation section, what was my advice to you if we had sines and cosines? How do you do that?
Use trigger.
Use a trig identity, okay? So we know that cosine squared plus sine squared equals 1. And yeah, we can plug in vectors to get all of these values, but that's going to be very tedious. Okay, if we know this right here, then we can do that. How do I do that?
That's a great question.
Because I is the x component and
Mhm.
j is the y component.
This is the x component, if we're thinking parametrically. So x over 2 is the same as cosine, right? This would be our vertical component, so we can think of that as y. Okay? So if we want to graph this without having to like follow our vectors as they draw it around, we can at least know that this is an ellipse with its center at 0, 0. Horizontally, we're going to go out 2 because x squared's denominator is 2 squared. Vertically, we're going to go out 1 because y squared's denominator is 1 squared. Okay, but since it is a vector valued function, vectors drew this, we need to notate its orientation. Okay, so as the vectors draw this ellipse, which direction does it rotate? Positive?
I am educated guess.
It's an educated guess. Okay. If we plug in 0 for t, we would get the vector 2, 0.
Yeah.
And if we plug in pi over 2, we would get the vector j.
So it does rotate.
So it does. Nice educated guess.
I just looked at the circle.
Failed to reject my hypothesis.
Okay, and I don't know why, but on last year's notes, I have this written. I have no idea what that
It's
means.
just done.
That's the code word.
You
see excellent.
I'm so confused
It
as to
must
how
have
we
been
got
some
this.
conversation that we were having, but I couldn't tell you what about.
And now you put it on this year's notes, so it's going to continue into next year as well.
I hope so. I hope
It's gonna
so.
be a mystery
Just confused.
forever.
Archaeologists
No
are
one
gonna
will
have
ever
to-
know why this was written.
Okay. We can take the limits of a vector valued function.
Oh.
No.
They never go away. do
Just
they?
things will
Yeah.
They like a parasite. They just exist.
No, I don't know where you're trying to go with that.
It limits evil parasites. My brother dropped some freaking knowledge on me yesterday. I was watching Climb Through the Wall with my family, and he was like, "It's just Magic Hitler."
Wait,
Well,
what?
yeah.
Oh.
That's kind of the
exactly,
point.
that was the point. Like,
Yeah, but the thing is, that movie, you already know the outcome of the movie because the other
I know. I didn't enjoy that. I have no idea what movie y'all are talking about.
it's fantastic.
Is it a prequel?
It is
No.
a
It's a sequel.
It's a
It's a sequel
sequel
to
to
the prequel.
It's a quill.
I'm everything though. I feel like they could have definitely mashed everything into like one movie.
They should have.
It's like
And not
So
finesse it.
Fantastic
they're just
Beasts
trying to get more money.
was the prequel.
Fantastic Beasts to Harry Potter.
Fantastic
No,
Beasts.
it's
Crimes of Grindelwald.
just like things just kept happening, and I didn't.
And J.K.
understand.
Rowling's over here like,
Okay, so if I give you a vector valued function and I ask you for the limit of said vector valued function, then you can take the limit at each component and you're good.
You can turn a limit into two limits.
No.
But why would you do that?
Well, it's easier.
I mean, because then you have two limits, and that's more than one limit.
That's
Just
limits
do
to
this,
break.
do this is to just not.
Limits are meant to be broken.
Yeah, I was thinking I can get my homework done.
That's not going for it.
And this doesn't.
What is the one?
Yeah, she's about 30 hours. So that's
Find the limit of the limit as x approaches. Find the limit as x approaches infinity of the limit
Okay.
as x.
This is our example.
C.
Oh, yeah. C is the constant in which we're taking our limit to.
Oh, we have a.
I have so much.
Okay, so if I want to evaluate this limit, we're going to evaluate the limit as t approaches 0 of e to the t, and then separately we'll evaluate the limit as t approaches 0 of sine of t over t.
I see what you did there.
The hope result. Can I have a calculus result?
Okay, so as we approach 0, e to the t goes to?
1.
Okay, kind of hoping for
So
a
it
quicker
would be
reaction
pi.
there, but that's fine. As we approach 0, sine of t over t,
0 over 0, so it's cosine of t over 1, which is 1.
do you remember that this is one
Yes.
of your special limits?
I remember.
No.
But good news, if you don't remember that that's one of your special limits, then you can use
L'Hopital's.
L'Hopital's rule to get cosine of t over t to still evaluate it to be 1.
Is the R for radius radical?
I would say it's more of like
Russia.
the
R
radius
for Russia.
analogy.
Why Russia?
R is
Our
radical.
function is using it.
Let's remind ourselves about continuity.
So,
Okay? These aren't normal functions, so we kind of have to redefine everything. But we're just going to connect it all together. Okay? If we had a regular function, our three
Continuity is hard.
our three checkoffs
oh,
for a function being continuous.
the limit
F
of x
prime of
exists.
x.
The limit exists there.
The point exists there, and the limit and the point are the same thing.
Okay. So do you really think it's going to be that much different for a vector value function?
Definitely.
Okay.
Well, I mean, it's in forms of t, and they're not actually functions. So.
Okay, so if we want our function r to be continuous at a,
Oh, good, not some q.
then the limit as t approaches a needs to exist. The function value at a needs to exist. And,
Need to equal each other.
yep. What?
So much nicer.
I thought it was pretty sketchy when letters came in the math, but now when there's no letters,
No, when there's no letters, that's
I'm confused on those letters. I'm
But
confused
it's
on those
not
not letters.
I'm just over here.
It has
man.
no
I'm
but point up there.
section 2.
At least my stats
Or not like
are
chapter
good.
2. Whatever, like the first thing we did this
Technically,
year.
yes,
It's like
because
I should've figured
where
it would
the
be
function
stats.
doesn't exist, the derivative.
Stats are so fun.
You know what we did in
Slope
AP stats
is
today? We went over our tests and then
Slope,
did nothing
right.
else.
Wow.
We went
and
over
then he gives us work days.
He gives us work days.
It was home. Work days.
Tomorrow you'll have most of your day to work.
Wait, are you gonna be here?
Yeah.
Then why do we have a work day?
Don't question it.
I would like you to tell me where this function is continuous. So write it down, talk about it with your pod. You are want to work there. You don't want to work there.
I do. I definitely
want
want to work there. I was
all
just confused because that's a gift from
TJ.
Well, I think it's the easiest to roll the domain. If I don't.
I don't think you have to find this. I just think you have to find the domain because the radical function is always defined. But let me check.
No, that's cheating.
It's,
Go check.
it's using your resources.
Not already.
Hey, if you take the hey,
If you plug in 0.
you get IJ. Igor.
Alright.
Constance.
Kaylee, where is this continuous at?
When we talked about the domain, we said 1 to infinity. I agree with that statement.
The domain is 1 to infinity and it's continuous at all those places.
Sounds about right.
Where would we need to be careful? We would need to be careful at asymptotes
Holes.
and holes.
But they're on
Corners are okay
Okay, I guess you're
because corners would still be continuous. That would be differentiability, and we could talk about non-smooth curves and yada 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 yada. Let's talk about the derivative.
We're just going quick today.
Yeah.
Definition of a derivative. Thanks for the
Oh boy.
You all know.
What is UOU?
What? What are you talking about? Okay.
Wait, RT is R prime of T?
Yeah.
They're the same thing?
No, the derivative of the vector function.
My text wrapping came a little early. Does that look better? Now it's giant. If I gave you a vector valued function, you would probably take the derivative just fine. But let's just go ahead and talk about why the derivative of a vector valued function is the way that it is. I'm going to go through the proof. Whether you write it down or not is up to you.
Is it
We
a
need
simple
it.
pool proof that I can give down to?
I'm just going through that. I'm going through the limit definition of. So I'm going to define our vector valued function to be f of ti plus g of t j. Which means our derivative is the limit as h approaches 0 of r of t plus h. Minus r of t all over h. Okay. Am I allowed to split up a fraction if there's subtraction in it?
Confused by what you're saying.
I can make this into two fractions that are being subtracted. Okay. So what should I group together? So I have f of t plus hi minus f of t I all over h
I'm just gonna watch you. Yeah.
minus, I told you you didn't have to write it down.
Wouldn't you just be able to take the derivative of the f component
Oh,
of
that's
the
too simple.
Hey Joe, what does it mean when I take the limit of this?
It's the derivative
Oh.
at the value.
Okay.
Yeah. That's where I thought this was going.
And what is, oh, this should be a plus. Very sorry.
Should it be a plus?
Yeah, she like
Because she moves the negatives.
because I moved the negatives around.
Mhm.
I kept this negative and this there. And then the limit of this just means,
Yeah, okay.
okay, so are you convinced that that's all we have to do with our vector value function? Which, if I gave it to you, would you have done that anyway?
Yeah.
Yeah, but we just needed to be sure.
It's a
Why
prime
can't we just
TJ.
accept that math is the way it is?
How many of you are going to be taking mathematics past calculus 3 in college?
I don't know.
I don't know.
Good question.
Probably
Okay.
there might be.
Did they make you take some algebra class?
Oh, sorry, was everyone done? That needed to be done. Okay, so write this one down. We're going to find its derivative. And then we're going to look at the vectors on the function.
It's just a curly prime.
You think you know it? Go ahead and find the derivative.
So there's two TJs.
What did you say it was, Joe?
Shouldn't it be I minus 2TJ?
Do you agree with Joe's derivative?
Yes.
Okay.
Times 2 times
So first of all, let's go ahead and look at what
Twice
the graph looks like. Okay. This is gonna have a I'm gonna look at R first.
Oh, okay.
Okay. This is gonna have a domain of all real numbers. So I'm just going to strategically pick some values. What about if t was -2?
Hold on, it'd be.
-2, 0. At 0, we would have 0, 4. What about at t equals 1?
You have.
1/3. And then 2 would be 2, 0. So what happens, we have this parabola. Okay. Now, the derivative gives us the slope of our curve. Okay. Well, let's talk about it. If I evaluate our derivative at 1, we have the vector 1, I, -2j. Okay. Well, that's our tangent vector.
So it's -1.
So here, at t equals 1, our vector over 1 down 2 looks like this. That's our tangent vector. Kind of cool?
Did you just play the points?
Yes, I did. I did. R prime of 1, I minus 2 times 1, give me the -2.
How does that?
So
Oh wait. I
Okay.
think
it's
it's
like -3.
Okay.
I'm confused.
So I plotted it from the points.
Derivative.
Okay.
You graphed the actual thing, and I thought you graphed the derivative, and I was so confused for a moment there. So,
Okay. We good? We're good. Okay. What if what's R prime of 0? If I plug 0 in, we just have I, right? Well, here is t equals 0. R prime of 0 is that vector. That makes sense, right? Okay. Now, let's go back to R prime of 1. I'm going to plot the vector. Well, I'm going to draw this in. What did I draw? Ah, I drew a normal vector. Our normal vector, I could have drawn it one of two ways, but that I drew 2i plus 1j. Our derivative evaluated at 1 gave us our tangent vector, making them orthogonal gives us our normal vector. Kind of cool. Normal vectors you use in physics, I think with centripetal force. Yes, no?
Centripetal force was a mess.
Yeah.
Okay.
I couldn't
You actually,
Like, did you ever have?
you actually did centrifugal.
There's vector addition.
Right? Like,
Yeah.
did you ever do something like that? Okay. It's been too long. Okay. Okay, let's go back to our concept of smooth. Some of you have been bringing that up. Okay, so let's talk way back to parametric equations. What was our rationale to figuring out if we had a smooth curve?
Where
The derivative didn't equal 0.
both of them, like if both of them equal 0 somewhere, then it was not smooth.
Okay, so if we had x equals and y equals, we looked at x prime and y prime, and we looked at if they were both simultaneously 0. Okay?
Or undefined. They were simultaneously undefined in the vector too. Undefined line.
I think we only have to worry about 0.
Hmm.
But I'm going to have to think about that. Well, okay. So, Joe, if any of them have a place where the derivative is undefined, we'd have some sort of discontinuity there already.
Yeah.
Testing to see if they're simultaneously 0 is basically going to give us where we have like a corner.
Okay.
Does that make sense?
Yeah. 'cause
Okay. So, yeah, it's not going to be smooth because there's going to be a break there. Because it's going to be discontinuity if you have anything undefined. Okay, so everywhere where a curve is smooth, well, what if we have a vector valued function? Okay,
Where
What
the derivative isn't 0.
okay, so we're going to be smooth everywhere. Except when our vector valued function is the 0 vector. So that means it's both components are simultaneously 0 in the derivative.
Like, what if it's like a negative and a positive and they equal 0?
Well,
Yeah.
but
You would
if
still
add
have,
them together.
They'd be separate components because one's with I and one's with J. Like I minus J stays as I minus J. Okay. So I'm trying really hard to make these vector letters bolded for you. Here's our example.
Oh no. You had to bring him in.
Yeah, I did.
You know, it's funny. They're used more to make curves than they are to make triangles when they come from the triangles.
This is
All of their relationships are based off of triangles, but
Trigonometry is almost just triangles.
okay, so our derivative. What's the derivative of our horizontal component? Okay. Plus, what's the derivative of our vertical component? Ah, that's nice. Okay. So, when does this equal 0? All of the pi's,
Oh, it would be 1.
all of the integers of pi's. Okay. Pi seems pretty. Okay, what about over here? This basically means if we set it equal to 0, we're talking about where the cosine is equal to -1. The odd pi's, like pecan. Glad you're paying attention.
Wake up, Dave.
So our curve is not smooth at t equals
2n plus 1 plus 2 pi. 2n plus 1 and 2n minus 1, 2n plus 2 pi.
Okay, so hold on. You both are expressing it different ways. So you're expressing it like this, and you're expressing it like this.
Yeah.
Either way, take it. -1 would be fine too. Right? This is what you said. April?
Yeah.
Okay. Okay. So I was like listening to you both and trying to like write it, and my mind wasn't. Okay. How many of you ate pie over Thanksgiving break?
Too much pie.
I'm not a pie eater. I know.
Well, I had
What?
pie, but it was like the kind of pie that
When you take a snow shovel to the pie, so you can.
Next time, Kaylee. Next time.
Well, I'm just like that.
You know Canada celebrates Thanksgiving in like October.
Yes.
I didn't know that.
It's a very
You
good.
just bought a pumpkin pie. You just like-
All right. Last thing we're going to talk about is if we have a vector value function, much like we can take a derivative.
It goes down.
We haven't done this yet. We can take it.
I did not see that coming.
No.
I-
Really should
It was coming.
Just like all of Calc BC
It's like-
jam packed into one day.
Right?
That's
Right?
what it feels like with every
Ah.
single week.
When we get to, like our whole goal with all of this mumbo jumbo that we're doing today and tomorrow is so that we can work with like velocity and acceleration functions in terms of the vector value functions.
Okay.
Okay? It's like this big crescendo up into the main event Wednesday.
So don't miss Wednesday.
Don't miss Wednesday.
Yes.
What I'm hearing is
DTI.
I think that's
What's
the
the
one.
advantage of having a parametric equation to be able to on Wednesday talk about velocity and acceleration?
This is in terms of time. Have the horizontal and the vertical.
We can talk about a particle moving multi-directions instead of just back and forth or up and down.
up and down.
Multi-directions.
I feel like we spent so much time on calculus.
I feel like we spent so much time on calculus in this class. I feel like we just doing a lot of diaries in here.
No, we're just
And Calc AB.
I don't know.
Okay? So if I give you an integral involving a vector valued function, then we are going to take the antiderivative of each component for our answer.
Oh boy.
Joe, what time do I need to get you going here?
When does class end?
40.
My next class is like 2 minutes away, so like 38.
38. Okay. It's downstairs.
Yeah, it's right down the hall.
Perfect. Okay, you're gonna have to help me because sometimes I could forget to make you leave. I don't want you to go.
If I go and turn right, and I can just walk straight.
Okay.
It's right.
Okay, so we're gonna take the antiderivative of e to the t
It's hard.
dt
DT
and multiply it by I. And then we're going to take the integral of sine of t, dt, for our vertical component. So, ladies and gentlemen, what is the antiderivative of e to the t?
E to the T plus C.
Okay.
We have to write plus C. Is this involved?
Well, you only technically have one.
C1.
Hold on.
No.
I'm doing it like this to help you with our transition tomorrow when we have limits of integration. Yeah, you heard me.
Okay.
What's the antiderivative of sine of t?
Negative cosine.
C2 minus cosine.
Now,
Minus C.
if we have a constant times I plus a constant times j, what we can do is we can write it like this. We can write our vector plus a
C on-
constant vector.
Okay, there we go. I was almost sad for a second.
Okay.
Wait, so that's a vector there though?
Yeah, because it's bolded. Yep.
So it's just C multiplied by I and J.
Yes.
It's a progressive plus C.
C is
Not
for
plus-
I really wanted to make you know that it was bolded, so.
very important. Do not forget your C.
You're bold and C.
Big C.
All right, Joe, I'm gonna let you pack up and I'll send you on your way. Let me take a look at our.
They're the same thing, aren't they?
Are these boldy boys?
We don't get bored.
I didn't get bolded
Okay,
this time.
what does that vector
But-
represent?
Who sucks the most?
What?
What does that vector represent?
An unchanging, unwavering, constant vector.
Is that something we're gonna get to later?
Just like time.
Right, like if we
Oh.
had a,
Dave,
um,
you went too far.
if we had an acceleration vector, then that would be the velocity vector. Like that's where we're gonna get
Okay.
here.
What?
So that's not like area under the curve or anything. This is dealing with something else.
Right.
A different spectral entity.
Well, because when we do indefinite integrals, it never represents area under the